You've been told your whole life that you can't divide by zero. It's one of the first, most absolute rules you learn in math, right up there with 1 plus 1 equals 2. It's treated like a law of nature, an unbreakable command, thou shalt not divide by zero. But have you ever stopped to ask, why? What if the reason wasn't just some random rule? What if breaking it would cause the entire logical structure of math to come crashing down? This isn't just about following orders. This is about protecting reality itself from a full-blown paradox. Let's start with something simple. Imagine you've got a pizza with 8 slices. You and a friend share it, so you divide 8 slices by 2 people. You each get 4. Simple. 8 divided by 2 is 4. But now, imagine you want to share those same 8 slices among 0 people. How many slices does each person get? The question itself just feels wrong, doesn't it? It's nonsensical. You can't give pizza to people who don't exist. This is our first clue. But the real story, the mathematical story, is way more elegant and a lot more devastating. That pizza problem is the gut check for most of us. At its core, division is really just one of two things: sharing or grouping. Sharing is the pizza example. 10 cookies for 5 friends, each friend gets 2, but 10 cookies for 0 friends. The whole concept breaks. There are no groups to put the cookies into. The other way to think about it is repeated subtraction. How many times can you take 2 away from 10 until you hit 0? Let's see. 10 minus 2 is 8, minus 2 is 6, minus 2 is 4, minus 2 is 2, and minus 2 is 0. That was 5 times. So 10 divided by 2 is 5. Now let's try that with 0. How many times can you subtract 0 from 10? To get to 0? Well, 10 minus 0 is 10. Minus 0 is still 10. Minus 0 is, you get it. You can subtract 0 forever and you will never ever get anywhere. You're stuck in an infinite loop of futility. These are great intuitive reasons, but they don't give us the cold, hard proof. For that, we have to leave the pizza behind and step into the world of pure algebra. Okay, here's the big secret. Division isn't really its own thing. It's just multiplication walking backward. When we ask what is 10 divided by 2, we're really asking, what number times 2 gives us 10? The answer is 5. In general, a divided by b equals c is just shorthand for c times b equals a. This relationship is the key to the whole mystery. Let's make this our first proof in blue. Now let's use this unbreakable rule on our problem. 10 divided by 0. We're looking for some number, call it x, where x times 0 equals 10. And right there, the logic breaks. You should feel a little chill. We all know the most important property of 0. Any number multiplied by 0 is 0. Always, no exceptions. This means there is no number x in the entire universe that you can multiply by 0 to get 10. It's not that the answer is hard to find. It's that an answer cannot exist. That's why any non-zero number divided by 0 is undefined. Okay, you might be thinking, that handles 10 divided by 0. But what about the really weird one? What about 0 divided by 0? Let's be strict and follow the exact same logic. This is our second proof in green. We're looking for number x where x times 0 equals 0. Now hold on, what could x be? What if x is 5? 5 times 0 is 0. Yep, that works. What about minus 17? That works too. What about pi? Pi times 0 is 0. The number of stars in the galaxy also works. Uh-oh, now we have the opposite problem. For 10 divided by 0, there was no answer. For 0 divided by 0, every single number is an answer. And if every number works, there is no single correct answer. Math demands precision. So 0 divided by 0 gets a special name. It's not just undefined. It's indeterminate. We can't determine which of the infinite possible answers is the right one. So 10 over 0 is a contradiction. 0 over 0 is total ambiguity. Both are forbidden. If the algebra still feels abstract, let's just look at a picture. One of the most famous graphs in math, y equals 1 over x. Let's give this proof a nice orange color. If x is 2, y is 1/2. If x is 1, y is 1. If x gets tiny, like 1 over 100, y becomes 100. Even tinier, y shoots toward a million. As x sneaks closer and closer to 0 from the right, y rockets up toward positive infinity. Now come at it from the left. If x is a tiny negative number, y becomes a huge negative number. As x approaches 0 from the left, y plummets toward negative infinity. So think about it. Right at x equals 0. The graph is trying to be at positive infinity and negative infinity at the same time. It can't be in two opposite places at once. The curve never, ever touches that center line. The graph itself is showing us this point is an infinite, unresolvable conflict. So far, we've seen why the rule exists. Now let's do what all great thinkers do. Let's break the rule on purpose and watch what happens. This is our final red alert proof. We'll assume just for a second that dividing by 0 is allowed, and we'll use it to prove something truly ridiculous. Start with a basic fact. A equals b, say they are both 1. Now multiply both sides by a. We get a squared equals a b. Next, subtract b squared from both sides. The left side becomes a difference of squares, so it factors. And on the right, we can pull out a b. So a minus b times a plus b equals b times a minus b. Everything so far is perfectly legal, but now we commit the ultimate mathematical crime. We divide both sides by a minus b. Remember, a equals b, so a minus b is 0. We are knowingly dividing by 0. Watch the chaos. The two sides cancel, leaving a plus b equals b. Plug in a equals 1 and b equals 1. 1 plus 1 equals 1, which means 2 equals 1. There it is, the catastrophic result of our crime. By allowing one single division by 0, we have proven that 2 equals 1, and it gets worse. Subtract 1 from both sides, 1 equals 0. And if 1 equals 0, then every number is 0. The entire number system collapses into a meaningless black hole. That is why we can't divide by 0. It's the guardrail that keeps math from driving off a cliff. Now, some of you are thinking of clever loopholes. What about calculus and limits approaching 0? Great question. But limits explore what happens near a point, not at it. We get infinitely close to 0, but we never actually divide by it. But my calculator gives me an answer. Yep. Some computers return special values like infinity or nine, not a number. That's not the math working, it's an error code, a flag that says, hey, you just tried to do something impossible. We've gone from a simple pizza to a proof that breaks reality. The rule isn't there to make your life harder. It's there to keep the world of numbers consistent and sane. It's not just a rule, it's the lock on the door to pandemonium. One more thing. I'm pinning a comment below this video. It's about a secret follow-up paradox, one that seems to break a proof you just watched. If you want to see it in the next video, go to the pinned comment and reply yes. See you there.